Welcome to this lab, everybody. We're going to be looking at working with microservices on Kubernetes and the autonomous database. So one request, please, if you're asking a question in a breakout room, obviously you need to come off mute, but except for when you're asking questions in breakout rooms, please do always stay on mute because it can interfere with other people presenting. First of all, just want to briefly mention the Developer Live session that is coming up on the 12th of November. For those of you who are familiar in the past with the Code One developer events, obviously we're not able to do that in person, but we are hosting a series of virtual developer events. You can see the details on the screen here. There are going to be a number of labs and presentations focused at developers introducing various developer technologies around the area of cloud native. And if you would like to register for that, this is a free event. You can see the bit.ly link at the bottom. It's bit.ly/developerlive_cloudnative_12nov. So please do feel free to register that. We will be putting that link in the chat later on as well. So, first of all, cloud native. It's a lot more than just a buzzword. Lots and lots of people say, oh, we're doing cloud native, we're talking cloud native and so on. But the reality is they are doing it. It sounds stupid, but in the last 4 or 5 years, we've seen a tremendous change from less than 23% of companies using cloud native. And those would generally be the early adopters like Netflix. Now, this year, well, at the end of last year, it was 84%, and I expect this year it'll probably be closer to 90%. And that's pretty much ranging from everybody from, new and upcoming companies like Retraced, who are using cloud native and blockchain to track the origin of leather shoes and other products, to companies like Monzo, who are creating online banks using cloud native technologies. So this is not a small footprint in terms of development, but also it's not a small footprint in terms of projects. Many of these organizations are using large deployments for their cloud native systems. So this isn't just people who are doing a little bit of testing and a little bit of playing around to see how well it works. Now, when we come to using cloud native, really cloud native is something that a lot of people talk about. There is an agreed definition, however, and that definition comes from the CNCF, which is the Cloud Native Compute Foundation, and really is about technologies to build and run scalable applications in a modern dynamic environment. And what do they mean by a modern dynamic environment? Basically, they mean public, private, or hybrid type of clouds. And these technologies allow the use of agile development methodologies. It enables you to use and scale the resources very efficiently so you can quickly respond to changes in demand. It also allows you to create portable applications because your applications, as you will see, are packaged in little containers, and that reduces the lock-in. You can take that container and you can run it anywhere. And it also means because it's inside a container, you don't have to worry about the language. What you're dealing with is externally the interface to the container. You don't get to see what's happening inside the container, so it doesn't matter what language or what framework you've used to build. Many customers are actually using multiple languages and multiple frameworks and choosing the one that's right for each individual microservice for that specific microservice. So it's a very polyglot environment. Typical examples, obviously, we've got the lightweight containers for microservices that we're going to be looking at a bit today, but also serverless applications where you focus on the code and you don't worry anything about the deployment because that's managed for you by your provider. There are a huge number of tools in the area of cloud native, particularly the common ones, however, are Docker, which is basically the standard for creating and running containers, Kubernetes, which is the standard in practical terms for running Docker containers and managing that run process. The FN project is a serverless open source framework that will allow you to run serverless applications anymore. And then many customers, many people use Terraform, which we will see in the lab, to actually build those services. So what does Oracle offer here? Well, Oracle obviously has a set of cloud native tools, otherwise we wouldn't be doing today's labs. And those providers, Kubernetes and Docker, serverless and streaming and so on. Those operate on top of the rock solid Oracle Cloud infrastructure, but you can work with many other elements as well. So you can choose your developer tools, you can choose your language and frameworks. Obviously, most services are based on storing and processing data. So you need a database and storage tools. And obviously, you may be familiar, but Oracle has a database. We have several databases, and we're quite good at it. So those are available in the cloud as well, along with many other developer operations tools for helping run and build and monitor and track what's happening in your containers. So let's talk about today's lab. Well, in today's lab, what you are going to do is you're going to set up a pipeline to deploy a Node.js application onto Oracle Kubernetes environment using the autonomous transaction processing database to store data. So in terms of the sequence, you're going to create a database. You're going to set up a Visual Builder Studio environment. So that was a product that you may have also heard called Developer Cloud Service. We've renamed it. We're making some changes to that product. You're going to set up the Visual Builder Studio Cloud Service. You're going to create the database tables using a pipeline within that. Using Terraform, then you're going to create a Kubernetes cluster in the Oracle Kubernetes environment, create a container for the actual application using Node.js and Docker, and then you're going to deploy that container onto managed Kubernetes and just test it out to make sure that it works. So what does that actually look like? Well, it's going to look like this, okay? So from an architectural perspective, you're going to use Terraform to manage the cloud platform to do the setup. You're going to have the autonomous database, the application running in Docker containers in Kubernetes, running in the Oracle Container Engine, and you're going to use Visual Builder Studio to set that up and manage it. So you're going to be following a tutorial. We will be providing links to the tutorial. It should have been in the invite, if I remember rightly. And you're then going to be using the Oracle Cloud Console to help manage the infrastructure. So for this lab, you don't need to install anything on your desktop. This will be all done using the Oracle Cloud Console, which gives you a command line environment where you can do things like Git and run Terraform scripts. We're going to be using Visual Builder Studio to run the continuous integration deployment chains. And as part of the Cloud Console, we'll be using the Cloud Shell. And then lastly, your application, which will be running in Kubernetes. Now, that's a brief introduction. The way this lab will work is we will have my colleagues, Emil and Lucas. They will be introducing you to the various lab sessions, explaining not every single aspect because that is covered in the tutorial, but explaining the main features and certain things you might need to be aware of. And then you will have a short break, usually of the order of 15 minutes, during which you will have the opportunity to do that step by hand. At the end of each break, we will be producing a poll just so that we can see how people are doing. So thank you very much for your attention here. If you have any questions, as Kostin said earlier, we will be operating breakout rooms. There will be people in the breakout rooms. Please do not go into a breakout room unless you have a specific question. But there will be support crew in the breakout rooms that you will have been allocated. So thank you very much, and back to you, Kostin.
Thank you very much, Tim. Thank you very much. I will take over the screen sharing. So as Tim explained, the materials can be found at the link on the left that is now displayed on your displays. And just to remind you again, the breakout rooms, in order to be able to go in the breakout room once the rooms are opened by our support, you just click join the breakout room, but do it later only when you need support. To go out from the breakout room, just press Alt Q or Command W. Emil, if you are ready to explain a bit the prerequisites that are needed for this workshop to go forward.
I can indeed. Let me just share my screen. There we go. Hi, Kostin. Good morning. And
Thank you. Good morning, Emil.
Good morning, everyone. So yeah, So as the people who have already sort of looked at the steps have seen, there is quite a bit of sort of prep work in the tenancy that is required before you get to part one, and it is really important that especially those who have not set up Visual Builder Studio before, and especially if you're on the trial tenancy, that you make sure that you go through this in the right way, because it really sets up the rest of the lab. So as a first step, let's just have a look at what those prereqs are, right? Because this is basically where we're setting everything up. So we're going to log on to the environment, which there were some things about which I'll get to in a minute. But once we've done that, we'll create a compartment that we're going to put everything in. We're going to have to set up our user to have a certificate and a token, so that we can log on with it, and not just as a human, but we can also tell the services later on to log on as us, which will be a requirement later in the steps. And then we're going to set up Visual Builder Studio and configure Visual Builder Studio to talk to our OCI account and set up an Oracle autonomous database. So I'll put a bit of detail into the first three steps here, and then we'll let everybody go and do that. So the most important thing, and I hope that everybody has already done this, is to get your trial tenancy done. It takes a little bit of time for the trial tenancy to get created, so hopefully you've already started that. Once that has been done, you can log on to your trial tenancy. Now, when you first get your logon, so the very first bit where you can log on, you tend to log on as a OCI user or a local OCI user rather than a federated user. So when you log back out and you log back in to OCI, you will see this type of sign-on screen, and it is important to make the distinction between a single sign-on user and a OCI user. You really have to make sure that you sign on as your single sign-on user, because that is integrated with the services like the Visual Builder Studio service. So I'm logging on as my single sign-on user, and I will let that log on for a second. There we go. So I'm now in my OCI tenancy. This is a fresh trial. That's because I want to make sure that I see exactly the same thing as everybody else is seeing, of course. So, excuse me. You will see on my screen, I've got Chrome is my, on the left-hand side, you see that I've got a little Chrome window. That's my environment, and then in Firefox I have the steps. So the first thing that we've got to do is create a compartment called CDT OK, so Cloud Test Drive OK. That we do by drilling out this pancake menu on the left and go all the way down. This is explained, of course, in the steps. And you go to compartments and you create a compartment there. So you will see that I've already done that. There's my CDT OKE compartment. So I've done that. Then I'll skip over that bit because the more important one is the certificate and the token for the user. So here we have a look at our user. So as you can see, it looks something like Oracle Identity Cloud Service and your name. So I happen to know who I am in this particular. And here is my user and then where I've got to go is you create a token. So this is an authentication token. On the left-hand side, you just hit create token. I'm going to skip back here. So that lives here. Auth tokens. You click there. I have already created one because I actually did this yesterday as a prep. As you can see on the data that was created there. So you hit generate token. That generates a authentication token that you can, like I said earlier, this is going to be required later. This is not what you log on with if you just, as a human being, you log on to the console, but you can use this if you log on to your OCI as a service. So, for example, later we're going to use Docker and the OCI Docker registry. That's where we're going to need that token as the password. So make a note of it. As it says in the instructions, you cannot retrieve that. You see it once. So make a copy of it, because OCI will not show you another. Then we also need an API key. So this is to have a public-private key pair, which is also going to be required later for some of the services to be able to log on. There we need to create a key. If you don't have a public-private key pair ready to use, because you've already used it in the before, what you can do is you can open a Cloud Shell. Now that is not actually explained in this bit with a screenshot, so I wanted to show that. So a Cloud Shell you can get and we will use that later as well. So you have to do that anyway. Later on in the explanations, it is explained better. But so on the top right here in my console, you can see the little icon here. If I click that, then I get a little virtual machine. That is a no-cost virtual machine that you can just do some useful things with in your cloud tenancies. So once that is loaded, you can use that. It's just a Linux environment. So you can everything that I'm doing here, you can of course also do in your own Linux environment, or if you have a Windows equivalent, you can do it there as well. And you can see that there are actually, this should be in 2 lines. I suspect. I've only just noticed that. So if we do we're just waiting for the Cloud Shell. There it is. So I'm creating a directory, and then I'm creating the keys into there. Now, like I said, you can do this in any environment. We're just using the fact that we have this environment ready to use, and there I have the key pair. So if I can't type. So there we have the API key.pem. And that's then what we can use to sort of add to the, so I'll skip over a few steps here because you just have to add that as per the instructions. The next important step is setting up Visual Builder Studio. So that, if I go back to the menu, I will show you where that lives. I'm going to close my Cloud Shell for the time being, just to give me a little bit more, that's here. Give me a little bit more screen real estate. Now, as I said earlier, for the people that have only just started to create their trial licenses, there tends to be a little bit of a delay in, well, first of all, you get your trial environment pretty quickly. That's a matter of minutes usually, but not every service has been configured at that moment often. So you get sort of a preview of what is going to be there. And one of the things that takes a little bit more time, and it varies a bit. Yesterday, when I was setting up this completely brand new trial, it took between 10 and 15 minutes for this bit here to show up. So it's under more Oracle Cloud Services and then Platform Services. That's where we select Developer. So if you don't see that, then don't, and you have a brand new fresh trial, then don't fret. It will come. It might take 10 or 15 minutes, but certainly if you log on again or something, then it will probably be there. So if you click on Developer here, so as Tim explained earlier, this was actually the Developer Cloud Service, which has now been renamed to Visual Builder Studio. So that's why in the menu it is still called Developer. It doesn't really matter. So here you can go and create instance. Okay, I created one earlier, of course. That's why it was open. 1 second. Get rid of that. Do that again. So here I'm basically saying I can't do that because I already have one, right? But you, in your steps, you would would go through it, you would create one, and once it's created, you can go to the little pancake or burger menu here and click on Access Service Instance, and that's when you go to your Visual Builder Studio environment. So here you have the Visual Builder Studio environment, and the first thing that you've got to do here is connect this up with your OCI account. This is actually still, this is being redeveloped at this moment, but for the time being, this is still sort of a standalone service from the rest of the OCI. It's not native to OCI. It basically sits a little bit outside OCI, which is why it doesn't know some of your OCI account details. So as the next step, what you're going to do is you're going to configure the connection between Visual Builder Studio and your OCI account. So you're going to click on OCI account and give it all of these details. So we will get there after the next break. I think we will go into a little bit more detail, but if you already get there, then the instructions get you through it anyway. But we will leave it there for the time being, and then we will pick that up after the next break, when everybody's got everything set up and configured and ready to go. So Kostin, back to you.
Thank you, Emil. Thank you very much for the good explanation for the prerequisites. I will take again the screen to show the one sec. Okay, so again, all these materials that Emil and Tim were talking about can be found at the link on the left. And shortly after the break, we'll have a first poll to see where you are on the on terms of having the steps performed. So now we'll have a 15 minutes break to let you work on the prerequisites, and afterwards we'll come back with our experts to show you the next steps in the lab. Thank you. And we are back. Thank you for staying with us. For next session, before the next session, we will discuss a bit with our colleague Łukasz, who will explain the lab steps for the part 1 and a bit of a visual builder explanation. But before Łukasz is starting, I will just announce a poll that my colleague in support will launch soon. So Łukasz, when you are ready, please start sharing your screen.
Yeah, hi Kostin, hi everybody.
Hi Łukasz, hope everything is okay and you did the prerequisites already.
Yes, it's nice to see you guys, everybody here. So let me share my screen and I will show you what we have to do next. So as Emil mentioned, at the last step on the first part, we created a Visual Builder Studio, and the next part it will be configuring the Visual Builder Studio, configuring the OCI credentials and creating the VM templates. So let me show you how it works. So basically, here is my created Visual Builder Studio instance, and here I am already logging into that instance. And the step which briefly Emil described before, which we have to do the first, we need to create the OCI credentials. And why we are doing this? Because Visual Builder Studio needs to interact with resources like compute resources in order, to spin up our build server. So in order to do this matching, you need to provide the following information, like tenancy OCID, user OCID, home region, private key, fingerprint, compartment OCID, and storage namespace. These things you've already gathered before, but I will show you one more time into the console how you can find it. So first of all, the main portion of information you will find under here under administration and tenancy details. Yep, where you will have the OCID of the tenancy. You will have also object storage namespace, which is required. And the following pieces of this information you will find here. First of all, the user details. You can click on your user. So please bear in mind that you need to be logged in as a federated user. So you will have to see this Oracle Identity Cloud Service before your user account. If this is not the case, please log out and log in again, because you won't be able to see the developer services, Visual Builder Studio instance. You won't be able to create it. Here you will get the information like OCID of the user and the API keys. So the authentication token and the API keys. As soon as you got this information, you validate your credentials, and if everything is okay, you save them, and now your Visual Builder Studio instance can interact with the services. The next step here, in order to create the build server, we need to create a virtual machine template. Yes, so I created a template for our lab, and as you create a template, you have a list of basically the software which you want to be included in that virtual machine. So the required packages are here. So basically Docker, kubectl, OCI CLI, Python, and so on. So this information you have listed here into the instructions. So please be careful what you are selecting. Yes, as you can see here, we have the software packages, and as soon as this is done, you create a template. As soon as we have a template, you go to the virtual machines and you create a virtual machine. So basically, this is already prepared the build server, which we will be using for creating CI/CD environment and for basically loading the data into and interacting with the Kubernetes cluster, as well as with the autonomous database. The last step from the preparation phase is provisioning the ATP instance. This we will be doing directly from the console. So clicking on the hamburger menu on the left, under databases, you will find autonomous database transaction processing. I've already created my database today a little bit earlier. You see that you need to be careful what compartment you are creating the resources in. So I have my CTD OKey compartment and my database. This database should be up and running within a few minutes. And what we can check now, and this is like a verification step that we have already database created, we can open a SQL developer and we will see that this database should be empty at this moment. Yeah, username is always admin, and the password is the password used while creating the autonomous database instance. So this is the easy way to see what we have in our database. And as you can see, we don't have any objects at the moment, any tables in our account. These objects we will be loading at the later steps. So let's go back now to our instruction. So this was the last steps from the preparation phase, and I will describe you the part one from the main step, which is basically setting up the visual builder project here. So what I have done, you have to go into the visual builder and create a project. Yeah, here under organization and projects, you should be able to see your project home. Yeah. And as you can see, I've already created my project. So this is the first step. The second step is to create a repository for your code. So you need to create a repository, and the link for the repository, which you will be linking, you will find in the manual here in the step 2. So here you have the link into the repository, which you have to use. And as soon as you are done with this step and you link your repository, what we need to do next is to clone this repository into your local environment. And we will be using Oracle Cloud Shell. So this allows us to, to don't store any code and interact with our cloud account from the local PC. You can make it directly from the console. So first, you need to launch. Here you have an icon which is basically spinning up the Cloud Shell. I have already opened it up here. So as you can see, I have already my Cloud Shell up and running. And what I have done, I've cloned this repository. Yes, so you can see that under the dev, I created a dev folder, and here is my cloud repository ATP Docker. And basically, this is the end of the step part 1 of the main lab. And in the next lab, you will have to load the necessary database objects, build application Docker container, and deploy Kubernetes cluster. These steps we will be sharing with you later on. That's it from my side, Kostin.
Thank you, Łukasz. Very, very detailed explanation. Thank you very much. Let me take back the screen. So again, I just wanted to remind you that the breakout rooms are for support only. So please stay in the breakout room only when you need support. Otherwise, please join the main room where the explanation will be provided by our support guys. Again, the materials can be found on the link on the left. And the trial can be created on the link on the right. So now we'll have another break to let you work on the next part of the lab, and we'll meet again in 15 minutes. Thank you. And hello again. Thank you for doing the steps for the part 1. Now we'll have another short poll to find out where you are in the steps. I just wanted to remind you that you will do this hands-on lab in your own pace. The trials are available for you for 30 days, so don't worry if you stay behind the lab as we showed it with our experts. Now, I would like to invite again Emil to discuss a bit about the part 2 of the workshop. Emil?
Hi, Kostin. Thank
Hi.
you. Yeah, I'm sort of gonna have a look at part 2. So in part 2, so when Lukas left us 15 minutes ago, we were at the end of setting up the Visual Builder Studio project, right? So we had just done the Git clone. So if I go and have a look at my environment, I just did an ls here. So I am in my, I can do it again, so I can show you where I am. So I'm in my ATP Docker, which I've just cloned into here, and then this is everything that is in there. So the next steps then are to go in. Basically, the reason that we did this is that we have to actually push some other stuff into this environment in order to ask Visual Builder Studio to go and deploy some stuff to our ATP instance. And the thing that needs to be there is the wallet to connect to our ATP database, because of course that is unique. So in order to do that, we go and indeed cd into that directory, and then we have to download the wallet of the ATP into the environment that I'm currently working. So we're of course working in the Cloud Shell. You could be working in any sort of client at this moment, as long as you have access to the cloud environment with the OCR command line tool. So this is the OCR command line statement to download the wallet to my local to the local place that I'm currently working. So it's OCI DB and then autonomous database, generate wallet, and then a number of details about that wallet. Of course, I've got to point it to the right autonomous database. So this is just a random example. That's not how it's called. I've prepared my statement here, or actually, I'll show you first. So if I'm in my ATP instance at the top here, then the OSID lives here. So I can just copy the OSID and then prepare that statement as I just showed you. So there's the statement, and I'm gonna just copy and paste that in there. And that means that I'm now downloading the wallet to this environment that I'm working. And there it is. So now I have a wallet.zip there, which is nicely downloaded. So the next steps are then to unzip that. And to go into the directory that has been created. Oh, wallet. There you go. So these are all the objects that you get with it. So this is just a normal wallet that you get with any ATP instance that you need to log on to the ATP instance. So then we need to make just one change from the default way that it's working, is that it's set the wallet location to a fixed directory. We actually want to change that into a parameter, TNS admin, so that the rest of our Git repository can use that. So if I copy and paste that and go back to my Cloud Shell, I'm actually going to explode my Cloud Shell up to be full screen here, so I can use it. And then, as per the instructions, I'm going to edit my SQLnet.aura. I'm going to take out the first line that is there now. I'm going to enter a new line and put that copied and pasted line from the instructions there. And write that, and I can close that to be a little bit smaller again if I want. And that is that. So now I need to push this back into my Git repository. So first of all, I need to go, well, just one step up. So I'll actually just go like that. And then I'm going to add that to my Git repository. Actually, I'll skip these steps because I actually did that earlier. So just in the interest of time, you're basically setting a few Git parameters and you're doing a Git push, which from that local clone pushes it back into where it came from, which of course was here. So if I click on Git now on the left side, I will see that I now have a wallet directory. And in that wallet directory, I have all of the files that we created there, including SQLnet.org, which is not the original, but the updated one. So that's the first step there, and the documentation also gets you through that. Now, the second thing is that we now have to go and ask Visual Builder Studio to use a few of those scripts that are there, including the wallet, to go and log on to the ATP directory and to run a script that creates all the data there. So we're basically using ATP. So you could, of course, use all sorts of other ways to connect to the database and create stuff in the database. In this case, we're using Visual Builder Studio as an example of one of the ways to do that. So you can, it's really just a nice thing to use in this way as an example. So the first thing that we're going to do then is we're going to go to builds. You can see I've got a few that I've already done, but you will not, if this is the first time that you go and have a look at this, you won't have any of these things. You go to create job, and this is where we're going to create this build job. So we're going to call it create DB object. So we're going to flip back and forth between instructions and cloud shelf, or sorry, cloud environment for a while. I'm going to have to call it the create DB objects too, because I already have one. And then I'm selecting the template. So this is the template of the build environment that it's going to be using. So this is just a virtual, as Lucas said earlier, he created this template earlier. So this is now the one that we are using. And then I've got to, first of all, select the Git repository that it's using. So that's my ATP docker.git. And then I've got to add a few steps for this build. So I'm clicking on steps here, and then I'm going back to the instructions. I skipped a few steps in the order. Well, I've done all of, there. So I've added the Git, and then as a step, I'm adding a SQL command line. So I'll go add step. So these were some of the things that you saw Lukasz earlier add to the build environment. These are the things that we can ask it to do, including SQL CL. And then we go back to the instructions to just make sure that we understand what all the parameters are. So we're now logging on to our ATP database. So to log on to our ATP database, we have a username admin and the password that you gave it when you, in the prereqs, last step of the prereqs, you created the ATP instance, you gave it the password. That is what we're logging on with now. So in our case, this is admin. I think I remember my password. This is the wallet.zip file that is now part of the Git, right? Because we just pushed that back in. We downloaded it to the local environment and we pushed it back in. And then the connect string is the connect string from the tnsnames.org. So if I just go quickly back to my cloud infrastructure here, if I just go back into the wallet directory, I can't type wallet to that. If I do a cat of tnsnames.org and explode that out maybe, then these are the standard TNS names connections that we have. So I'm gonna use ATP OKE_hi. Doesn't really matter what I use. And then just to go back to the instructions. So this is, so in the example, it's JLEOOW_hi. That's, of course, you've got to change this into the actual one that you are using. And then the script that we're running is one from the Git repository a1/create schema.sql. So that is already in the Git repository that we cloned earlier. And I go back here, and that's the one that I put. So these are all the steps that you need here. And then you can save, that's very important, and hit build now. So I'm going to save this and hit build now. Now, once I've done that, it is important to understand that you will see here, it says wait for executor. Now that is, so it's going to get me a build machine from the Visual Builder Studio environment. So this is where at the start of the steps, when we configured it to connect to OCI, it is now creating a virtual machine in OCI to do these steps on. And then it's going to, the first time that you do this, so the very first time that it's going to create a build machine, it takes about 10 minutes. So that is quite a long time. And there is no way really to speed that up. Every second or so, we're going to use another build and then another build in the next couple of steps, in steps 4 and 5. When the build machine already exists, it is a lot faster because it can just create it because the virtual machine stays there. But the first time that you create this, or the first time after a while that you go and do this, it takes a long time for that virtual machine to get configured, to get created and then get configured with all of the tooling that we asked for it to be put on there. You can go and have a look at the build log, and you will see here it's basically only just started, right? So you won't see much progress there for another 10 minutes. And that, if we go just back to the steps, once that is done, you can go and verify the results by going and have a look at that at the log and all of those sorts of things that I've just shown you earlier. But you won't see much there until the machine actually exists. And like I said, once the machine exists and has all of the tooling on, then every next step will just take seconds rather than the 10 minutes. But the first time it's got to be configured. So one of the things, once that is done, you can go into your SQL into your SQL Developer web environment and go and have a look to see what was there. Now I'm just going to show you that because right. So I already had a build machine, which is why this went a bit faster. So I'm going to go into the build log, and I have to say all of these errors are also normal because I actually ran this earlier. So it's now going to say, oh, you're trying to insert data, but it was already there. You should normally see, actually, I'll take you back to the original time that I built that. This is what your output should be, right? So it's just going to load the script, and the script basically just creates a few tables and it does some inserts. So you see all that. Now, if you're waiting for those 10 minutes, what might be an idea is to just leave it running, leave it creating the machine, and just go on to part 3 to create the managed Kubernetes environment, the OKE environment, because that also, we're using Terraform to go and do this, and Lucas will go into a little bit of detail there. But actually, once you've kicked that off, that will also take a while to get that configured. So whilst you're waiting for the first one, you could start this step, part 3, and then just go back just to make sure when that is all done, you go back to the end of part 2 again, just to do that results verification, just to make sure that all of those rows are loaded. Because if the rows aren't loaded, then later when you go and deploy your application, it won't have any data to show. So it's important that this thing gets done properly. And that's it.
Thank you, Emil. Thank you very much for the explanation. So I thought from the poll that you are still in the previous steps. So don't worry. Again, you have all the time. You have 30 days to complete all the steps. So to do the lab in your own pace, there is no problem. And our support guys will be there to help you.
And may I actually add something to that, Kostin? So yeah, it's absolutely right. The first time that you do this. Actually, I have done this lab a number of times, and very rarely do I finish within 2 hours. So it's completely normal that some steps take a little bit longer the first time that you look at it. So absolutely, I would recommend to everyone to just go at their own pace, but then not stop after 2 hours, but get back to it and see it through to the end.
And another thing, the trial will have all the other services, so you can try any service that you may want in the trials that you already have. So again, we'll have a short break to work on the next steps the lab that Emil just showed you, and coming back in 15 minutes. Thank you. And we are back. Thank you very much. I hope you did the part 2, as Emil was explaining. So again, as you are used, another poll to see exactly where you are. And following, we'll discuss again with Łukasz to find out where he's performing the lab steps and explaining a bit the part 3 and the part of Terraform. So Łukasz, whenever you are
hi,
ready.
Hi, Costin again.
Yeah.
Let me share my screen.
Perfect, we can see you.
Okay, so now we are at the part 3, and this means that we need to now spin up and manage the Kubernetes cluster, and we will use for this purpose the Terraform. So you had such brief info. What is it? So basically, Terraform is an open source tool, open source infrastructure as a code software tool created by HashiCorp, where you can define and provision your infrastructure, data infrastructure, using declarative language like HashiCorp configuration language, or optionally you can use also a JSON file. So Terraform manages the external resources. Yes, so it's not just for our Oracle Cloud infrastructure, but it might be any other public or private infrastructure. And these third parties in Terraform are called providers, and OCI is one of them. So what we will do now, first step, basically you need to collect again the same information while you were creating the OCI credentials for Visual Builder Studio instance. So I will skip this time because we already gathered this information. And in the next step, we have to set up the Terraform parameters and run the script. We will be using Terraform directly from Cloud Shell. So as you can see here, I am already connected here to the Cloud Shell. You have to navigate when you clone the repository. You have a folder. You have a folder called Terraform -0.12. In this repository, you have the required files. So basically, you have some templates, Terraform files, TF files for describing the Kubernetes cluster, describing the network, describing the provider, which I mentioned before. So basically, this allows the Terraform to recognize on what kind of infrastructure we will be deploying the required resources. And we have also variables file, and the one which we have to modify, Terraform TF-vars file, which basically here includes the information which you gathered in the step file in the first step. So like tenancy OCID, compartment OCID, region, and here you can specify the worker node shape. This information, so you need to modify this file using your preferred file editor like VI or Nano. Save this file, and we should be ready to test. Basically, first of all, you will be now doing some set of commands. You need to type set of commands. First of all, first command is terraform init. Let me show you.
Yeah, 69.
So in terraform init, basically in this directory, all dependencies are downloading. As soon as this is done, we can run a terraform plan, which basically will show us what is going to be created. Yes, we described our required resources within the files which I showed you before. And at the moment, as you can see, there are no changes because I've already deployed the Kubernetes cluster. So this is the expected result. And the last comment, if you want to deploy the resources, you will use the terraform apply command. I will not do it because it's already deployed. So as you can see above, I have already my Kubernetes cluster created, just to make sure that you can find it here under hamburger menu and developer services. Here you will find the Kubernetes cluster. And this provisioning shouldn't take more than 10 minutes. Yes. As of our infrastructure description, we created the network for this Kubernetes cluster. We created the Kubernetes cluster and the node pool, which is here. And we have, in the node pool, we have three nodes available. So as soon as the step 2 of our of this part is ready, now we can validate if basically this kubectl works, and we can basically talk to our infrastructure. Just a second. To specify the right post. Okay, I shouldn't be in this folder. Okay, let's skip it as we don't have so much time. And as soon as we have provisioned this, the two files are created. Basically, the myconfig file, which it will be using for interacting with the cluster, and this is also used for accessing the Kubernetes management dashboard. And the second created file is called terraform tf state. So basically, this is the file which contains and describes the details of the created resources. Terraform it has characteristic of immutable infrastructure. So as soon as you created some resources, you don't want to change them. If you want to make some changes, you basically delete the resource and recreate it from the scratch. After we validated this, at the last point here, steps, is to create the secrets. So I will not show because we are running out of time. We validated, we see that our nodes are up and ready, and we create the two secrets. One secret is to allow to pull images from the private repository, and the second one is for making the database wallet available as mounted volume inside your pods. And this is the end of the step 3, part 3. So I'm handing back to you, Kostin. Thank you.
Thank you, Łukasz. Thank you very much. So following all the steps one by one, it should get you there to create the Terraform scripts and to advance to the next steps. In the interest of time, next break it will be only 5 minutes, and we'll hear each other again with Emil to explain the last parts, 4 and 5, and then to wrap up the event. So let me share again. See you in 5 minutes. Thank you. And we are back. Thank you very much. So now we'll move on with the part 4 and 5. And Emil, please let us know where you arrive with the steps and what's next.
Okay, thank you very much, Kostin. So yeah, in the interest of time, I'm gonna actually spend not that much on describing steps 4 and 5. So because we want to finish at the top of the hour, we have a few things after I am done. So I would urge everybody to just stay for an extra 5 or 10 minutes. These labs are live, so sometimes we run over a bit. But so step 4 is building the container image and then storing it in our Docker registry, the service that is part of your OCI tenancy. And then in step 5, we're going to deploy this as an application into our Kubernetes cluster. So the important bits about step 4, like I said, in the interest of time, I will let you just work through the steps. They're all very logical and just do what it is that they say. One of the things that I wanted to highlight is that we're going to do another build job here, as I was talking about when I was last on before Lucas was on. And as part of the build job here, the steps that we have to do are described here in step 3. So we create a build job, we point it to the right Git, and then we add a number of steps. So in this job, we're going to build the Docker. We're going to do a Docker build. So the important bit here is that we log on to the right thing and that we give it a good name. So what could be somewhat confusing, what always confuses me here, is the image name. So the image name must be my tenancy storage namespace, i.e. that's that storage namespace that you looked up a while ago, and then your repo name and your image name. So both the repo name and the image name you choose at this moment. You don't have to go and get that from somewhere. You actually choose. So an example would be, for example, your initials _ repo /ATP01 for the image. So then your repo name would be that and your image name would be that. So if I just go and have a look at my own environment here, so in the config things, so this is where it's configured. The Docker login was already set up earlier. So the Docker build, this happens to be my storage namespace. I've called it EGR, which are my initials _ repo, and then the name of the thing is ATP01. And then after that, we're also doing an image push, which again has to have the right image name. So those two image names have to be the same. So what this step does is it builds that Docker image and it pushes it to the registry. And then if I go back to the builds, you can see that is actually, if you go, I ran it earlier, and you can see that it's doing all the pushing and the creation, etc., etc. So if I go back to the instructions, so one of the things that you've got to do as well here is before you do the push and the creation, you've got to actually edit a few of the things to make sure that you point to your database. So you've got to do an edit there in step 4, which I won't show you, like I said, in the interest of time, and then run the build job. Then in step 5, we're going to go straight on and we're going to deploy this thing. So again, you've got to create a new job, a new build job to do the deployment in. Some of the important things here is that you have to point it to the right OSIT and the fingerprint and the tenancy, and then you have to use that private key that we created right at like 2 hours ago. So you got to have that private key there, and then you basically run the kubescript.sh, and then that is part of the Git. So we gave that to you, and that runs, and that sets up the thing within. Oh, sorry, one more thing. That kubeconfig file that Lucas was playing with earlier, that Lucas showed, that was created, that has to be uploaded. That has to be copied into your config here, and you've got to change the atp2.yaml in your Git as well to make sure that you point to your image here. So that is on line 17. You could go and change that. Once you execute that, you will actually see that let me just go to the execution log here, deploy there. So I'm hoping that this does it nice and quickly. It doesn't at the moment. Okay, don't know why. So I'm just gonna give it one more chance to show me that. And if it doesn't want to show me that, I'm going to skip that. Like I said, in the interest of time, you will see that it will basically try to push this into the Kubernetes environment. And then finally, what we're going to do is we're going to have a look at the Kubernetes environment and go. So I tested this out earlier. So I'm going to go kubectl get nodes, which will hopefully show me what the nodes. So here are my 3 nodes with their external IP addresses. Then I'm going to do a kubectl get service, which is going to show me my ATP2 service. There's my ATP2. That's what we call this thing. And then in order to see this visualized, this application, I'm taking one of these external IP addresses. We haven't actually configured a load balancer in front of this, so we're just going to go straight into one of the nodes. And I'm going to go that IP address. And I have to select this port number here. It's a bit fiddly, but the instructions tell you that exactly. There you go. And I'm going to go, there's my application running. And you can see from the fact that I've got all of these things in here that I've actually loaded this data into the database. As you can see, I've loaded it a number of times. So there's a number of copies there. This is all the data live from the database. The application is loading. It's got all of the data here. If the application loads and you don't see any data here, then that means that your connection to your database isn't configured right. So you've probably done something not quite right with the wallet or with the secret that you created, as Lucas was saying earlier. So have a double check of those things. But this is roughly what it should look like. Except you should only have one row, because you should only have loaded your data once rather than multiple times that I've run it. And that's that. Not quite the 5 minutes that I planned, but still.
Okay, thank you very much. Thank you, Emil. I hope everyone will have this big sail image at the end of the lab. So again, I will share my screen to wrap up the last minutes. You can find the lab materials at the link on the left. You can create your trial account on the link on the right. Don't be worried. You can run these steps anytime during the next 30 days. So this is how much your trial will last. Do it in your pace. If you need support, you can contact Oracle anytime. And at the end, I just wanted to thank the whole team that participated today in our event. So for the breakout rooms, our engineers in support, Sid, Stefan, Bogdan, Michael, and Kadej, thank you very much. And the event producers, Tim Graves, which is the lab owner, Emil and Lukáš, thank you very much for your good explanations. And Ettore and Jan, who are behind the scenes to make it work. Tim, if you want to say some closing notes, and we'll have the last poll of today as a short feedback on what you see. Thank you very much.
Okay, thank you, folks. So whilst Kostin is just closing that down and we have the closing video, I would just like to say myself, thank you very much for joining this. Hopefully it's been interesting. We're obviously aware that not everybody will have finished everything. So as Kostin said, the tenancies do last for 30 days. So please carry on with the lab if you'd like to. And the presentation recordings will be shared. So Ettore will be sending out a recording of that. Just to remind you what the lab is about. Basically, what you will have done, if you got to the end, is you'll have created a autonomous database. You'll have created a Kubernetes cluster using Terraform. You will have used a workflow in Visual Builder to populate the database, and then you will have created a Docker container installed in Kubernetes and running it, which will access your data. A little bit of information about a couple of other events we have coming up. So again, the Developer Live event, which is on the 12th of November, is focused around cloud native. So that's at bit.ly/developer live cloud native _12th November. That is a free registration and a free event. And in terms of the virtual labs series, we have a lab scheduled for the 25th of November, where we will be looking at Helidon, which is a microservices framework to help you build cloud native deployments. And basically what that lab is going to do is to show you how you can use Helidon to REST enable existing code, apply authentication, manage configuration, connect to a database, and set up communications between microservices. This lab will be in the same format as we've done today, but it's part of a larger lab, which also looks at packaging those using Docker and, again, deploying using Kubernetes. So if you would like to do the lab, you will also have the option of carrying on with the larger lab. As Costin said, a big thank you to everybody for joining today. It's very much appreciated. We hope you've been finding it useful. And again, thank you very much to the team. And with that, I will say thank you very much to everybody, and hopefully we will see you at the next set of events.